Unintentional circuit joining can present potential hazards when installing a generator with an automatic transfer panel. If two circuits are inadvertently connected, and one is on the transfer panel while the other is not, it creates a dangerous backfeeding voltage situation. When the generator activates, voltage is present on the non-transferred circuit. This backfeeds onto the main bus and power lines, potentially harming unsuspecting individuals or electric utility workers. Backfeeding voltage also causes electrical fires by overloading circuits or causing arcing, damaging equipment, structures, and posing a significant safety risk. While responsibility for existing wiring rests with others, taking reasonable precautions is vital. Firstly, conduct a thorough inspection of the existing house wiring before connecting circuits to the transfer panel. Look for loose connections, improperly covered splices, or anomalies. Secondly, testing for voltage at the main bus with the generator on is a good idea, but it doesn't account for connections through switches. To mitigate this, manually operate all switches associated with circuits connected to the transfer panel. Ensure switches are in the off position before connecting the circuits. Preventive measures include firstly, clearly labeling circuits in the panel and at all outlets to avoid confusion during future maintenance or repairs. Secondly, install ground fault circuit interrupters, or GFCIs, on all circuits connected to the transfer panel. This provides additional protection against backfeeding and electrical fires. Thirdly, educate homeowners about unintentional circuit joining hazards and the importance of regular electrical inspections. While unintentional circuit joining is rare, it's essential to be aware of its consequences and take precautions to minimize risks. Thorough inspections, voltage testing, and preventive measures help prevent dangerous situations and ensure the safety of customers and the general public. It is crucial to consider the electrical code. The National Electrical Code, or NEC, provides guidelines for safe electrical installations. Article 702.6 addresses optional standby systems that could be applicable to generators. Article 702.7 covers the transfer equipment. The transfer equipment must be suitable for the intended use and designed and installed so as to prevent the inadvertent interconnection of normal and alternate sources of supply in any operation of the transfer equipment. Article 702.11 covers the connection of optional standby systems, ensuring they comply with applicable articles of the NEC. When testing for voltage, use a calibrated voltmeter. Measure voltage at the main bus and at each circuit connected to the transfer panel with the generator running and the main power off. Look for any unexpected voltage readings that indicate backfeeding. If you find any anomalies, disconnect the affected circuit and investigate further. Remember to follow lockout/tagout procedures when working on electrical equipment. Always to energize circuits before working on them, and use appropriate personal protective equipment, or PPE, such as insulated gloves and eye protection. Document your inspection and testing procedures. Keep records of your findings and any corrective actions you take. This can be helpful in case of future issues or liability claims. When informing homeowners, explain the potential risks of unintentional circuit joining in simple terms. Provide them with written information about the hazards and how to prevent them. Emphasize the importance of regular electrical inspections by a qualified electrician. In addition to GFCIs, consider installing arc fault circuit interrupters, or RSIs, on circuits connected to the transfer panel. RSIs provide additional protection against electrical fires caused by arcing faults. When labeling circuits, use clear and durable labels. Include the circuit number, the area served by the circuit, and any specific loads connected to the circuit. Use a circuit tracer to identify circuits and verify the connections. A circuit tracer can help you identify the path of a circuit and locate any points of unintentional joining. Consider using a surge protector on the generator output. A surge protector can help protect the generator and connected equipment from voltage surges. When installing the transfer panel, ensure it is properly grounded. A proper ground connection is essential for safety and to prevent electrical shock hazards. Use a torque wrench to tighten electrical connections. Properly tightened connections are less likely to loosen over time and cause problems. Inspect the wiring insulation for damage. Damaged insulation can create a shock hazard or cause a short circuit. Replace any damaged wiring. When working with aluminum wiring, use antioxidant compound. Aluminum wiring can corrode over time, which can lead to loose connections and overheating. Antioxidant compound helps prevent corrosion. Be aware of the potential for electromagnetic interference or EMI. EMI can interfere with the operation of electronic devices. Use shielded wiring and filters to reduce EMI. Follow manufacturer's instructions for installation and maintenance of the generator and transfer panel. Improper installation or maintenance can void the warranty and create safety hazards. Obtain all necessary permits and inspections. Electrical work often requires permits and inspections to ensure compliance with local codes. Consider the load on the generator. Do not overload the generator, as this can damage it and create a safety hazard. Use a power meter to measure the load on the generator. Size the generator appropriately for the load. The generator should be sized to handle the maximum load that will be connected to it. Consider the voltage drop in the wiring. Voltage drop can reduce the performance of electrical equipment. Use appropriately sized wiring to minimize voltage drop. Consider the ambient temperature. High ambient temperatures can reduce the capacity of electrical equipment. Direct the equipment accordingly. Consider the altitude. High altitudes can reduce the output of the generator. Direct the generator accordingly. Consider the humidity. High humidity can increase the risk of electrical shock. Take appropriate precautions when working in humid environments. Consider the presence of flammable materials. Do not install the generator near flammable materials. Consider the presence of corrosive materials. Protect the generator from corrosive materials. Consider the presence of vibration. Vibration can damage the generator and connected equipment. Mount the generator on a vibration isolating base. Consider the presence of dust and dirt. Dust and dirt can clog the generator and reduce its performance. Keep the generator clean. Consider the presence of pests. Pests can damage the generator and connected equipment. Protect the generator from pests. Consider the presence of lightning. Lightning can damage the generator and connected equipment. Install a lightning protection system. Consider the presence of ice and snow. Ice and snow can damage the generator and connected equipment. Protect the generator from ice and snow. Consider the presence of wind. Wind can damage the generator and connected equipment. Secure the generator to prevent it from being blown over. Consider the presence of flooding. Flooding can damage the generator and connected equipment. Install the generator above the floodplain. Consider the presence of earthquakes. Earthquakes can damage the generator and connected equipment. Secure the generator to prevent it from being damaged by an earthquake. Consider the presence of terrorism. Terrorism can damage the generator and connected equipment. Protect the generator from terrorism. Consider the presence of cyber attacks. Cyber attacks can disable the generator. Protect the generator from cyber attacks. Consider the presence of electromagnetic pulses or EMPs. EMP can damage the generator and connected equipment. Protect the generator from EMP. Regularly inspect the generator and transfer panel for damage. Repair any damage promptly. Regularly test the generator and transfer panel to ensure they are functioning properly. Keep the area around the generator and transfer panel clear of obstructions. Store flammable materials away from the generator and transfer panel. Have a fire extinguisher readily available. Know how to operate the generator and transfer panel safely. Provide training to anyone who will be operating the generator and transfer panel. Keep records of all inspections, tests, and maintenance. Review the NEC Article 700, Emergency Systems. Article 700.3 covers tests and maintenance. Emergency systems shall be tested periodically on a schedule acceptable to the authority having jurisdiction to assure their maintenance and proper operating condition. Article 700.4 covers capacity. An emergency system shall have adequate capacity and rating for all loads supplied by the system. Article 700.8 covers signs. A sign shall be placed at the service entrance equipment indicating the type and location of on-site emergency power sources.